Hello guys, I'm back. We got power to the radio. It does need a really serious alignment job done, so all I can really pick up really decently is the generator, and it's rather weak, but it's way out of line, and I kind of knew it would be because the IF cans, the tuning capacitors in those are copper plated, and several of them were pretty badly corroded, so I had to unscrew the screws out and open them up, desolder them, take them out, clean them up real good, and then put them all back together. So it's amazing it's even picking anything up. And there was a few other things that got cleaned up and got knocked out on the oscillator coils too. So, but it is functioning. So, as you can hear. Now, there's a few things about it I've got to, well, besides doing alignment, there's something I got to fix first. And a wiring error. And yes, I make wiring errors. In the volume control, which is, if I can find myself here, is right here. Okay. Now, one end hooks into the cathode, which then also hooks down and ties into, well, it's a 10 ohm resistor, but it's a bias resistor. Picks up -3 volts there. And then the other end comes across and, of course, naturally hooks into the secondary of the second IF can. That's where it's going to pick up the signal. And then also the AVC circuit going across here. Now, when I hooked this up, well, I made an error. And what I ended up doing was I ended up getting this connection crossed. Basically, it's hooked up backwards to a certain extent, but I'm also feeding the negative over onto this side into the on this side into the IF. So it's off that way, and as it is, what happens is it's got a little bit of volume control, but you come off of when you just first turn it on, you have low volume, virtually none, like you should, and it quickly picks up to just a very low level, and then there's nothing until you get to the end, and then it shuts back off again. So anyway, I got to fix that. That's one of 2 wiring mistakes I made in this radio. The second one I already got fixed, and it had to do with the connection of the tuning condenser, and in this circuit here, I ended up connecting it not across the coil, but actually directly on the other side of this cap, directly onto the tube. And that changed to, with this cap in here, that changed how the signal passed. Basically, the tuning condenser did absolutely nothing. So anyway, that's fixed. So anyway, everything in here that's a patter or trimmer is way out of whack, and like I say, it's amazing it's even getting a signal through. So I'll have to get alignment done on it and everything. Now, a couple other little things of issue was, which was real simple to fix, was it had a little bit of a squeal to it at certain levels of volume. Well, it was real easy to fix. I had just to move this a little bit. It was more over this way. I ended up shoving it down and over this way, and that quieted a little bit. Still had some, and it happened to deal with these two capacitors here, and I moved them closer to this way, so these wire leads were closer to the can here, and that quieted that up. So it's like less than a quarter of an inch movement, and it got rid of the squeal. Now, I had a question about in one of the comments, and I hadn't gotten around to it yet, but I wanted to talk about a little bit. It wasn't on this particular, on the last video, it was on a video before that. It had to do with bias and stuff. Now, I'm just going to kind of go over this a little quickly. I will do a video in theory to deal with it a little more in depth, but it's more about the AVC voltage itself and how it's generated. Various radios have various techniques of doing it. Now, this is using a 6Q7, which is a dual diode triode. It's also a later version of it is a 6SQ7, which doesn't have a grid cap on it. They actually put the grid on a pin and below. Same basic tube though. Well, in this radio, first we'll start with this one. In this radio, this diode here on pin 4, which, you know, you got the plate here and it's a diode with the cathode. The cathode becomes the negative for either one of the two plate diodes for the plates. The signal, that's the actual signal diode, and it's the rectifier that's going to rectify the signal coming through the IF and rectify it out and get you your excuse me, your audio. Now, on this radio, it's a little different design because this diode is also acting as partial, establishment of the AVC. And the way it does that is the load is across this resistor R8, which is your volume control, and when you follow the signal through, and as it is rectified, it'll have a certain amount of DC level to it that will establish a negative voltage on this side and a positive over here. So you have a negative voltage coming through down this line, and that follows down this way and up through the coils, and then that's what's feeding the mixer tube input grid. And also it comes through here and comes up through the secondary here and feeds the grid for the 6K7, the IF tube. Now, they did on this radio, they wanted to make sure that they'd established at all times a negative voltage, a certain set bias voltage. So they're actually feeding already a negative 3 volts. If there was no signal at all, it's already established with a negative 3 volts coming in. And that's one way of doing it, but they did it on this radio. In order to get a little extra negative on this side and get the AVC to work correctly and to kind of take out any type of ripple, they use a second diode here, which then feeds over here and actually will establish a little bit of a load on R7. These two will combine. The primary is on the volume control, but there is a certain amount that develops here. The two will combine and will act as the full AVC voltage. Now this is impressed across C9 and C1. You do have an RC factor here, RC time constant between R7 and C9, R1 and C1. Those are established there so that it's signal strength more that changes the bias. So when you got a strong signal, you get a lot of negative voltage, reduces the gain of the tubes. When you got weak signal, less negative voltage, so the gain of the tubes increase. You want that. You don't want where you're listening to, say, some music or something, and they go to highs and lows in the audio itself. You don't want that changing your volume. So that's why these capacitor resistors are here, is to try to keep that from happening and only letting the signal do its job. But anyway, that's basically how it works. Now, you don't need two diodes to make the thing work. All you need is just one diode, and you'll have your filtering circuit, but then you'll have a load resistor. It may or may not be the volume control. Some have a second resistor in it they're going to have as a load going to ground. But either way, you can get by with just one diode, and a lot of your cheaper radios did that. Some radios use both diodes. What you would find, if they're having an actual AVC diode as one of the diodes and the other one the signal diode, is they'll either put a high resistance resistor in here, or more aptly a capacitor between the two diodes, so they can feed some signal also onto the AVC diode. So, but some will just short these two diodes together and just make it just one diode. Some will use tubes. There are some tubes that only have a single diode in them, but you don't need both diodes to make AVC work. Now, and I hope that kind of answers it. Like I say, I'll do much better a theory thing on that in the future, and to deal with that. Another question, and it's my fault, and I apologize for this, was talking about these coils and how they connect in, and about the switch and how it's operating. And I meant to say it, and I didn't. I got more involved in this is how it connects up more than how it actually operates. But what actually happens is when you start switching the switch and changing the bands, is it starts shorting out coils. When the thing is in broadcast, the most number of coils are connected in, mostly in a series type circuit. You can see it real easy on the antenna coil here, but as you flip the switch, it'll start shorting out those coils. And like I say, it's easier to see it right here. This is kind of convoluted the way they drew it, so it's kind of hard to see. But right now, everything goes clear across all three of these coils. They're all in series. When I flip the switch, basically that's just shorting these two leads out, which basically shorts out this point right here. So now it just jumps through, comes through here, comes up, and just goes through these two coils. Flip it one more time, and it shorts out from this point all the way to this point. So now like your AVC would come through here, follow through, and come up and come through this coil. The same way your signal comes through, as you flip the switch, you're just cutting out the coils. On this one here, it actually cuts them out and shorts them out, and that's all it's doing. So I hope that answers that. That's all the switch does, is just short out the individual coils so that they're taken out of the circuit. And now the other thing was about this again, about this large pattern back here, and I guess I didn't go into depth on it too much. It has, I think, only 2 plates in it. It might be 3 plates in there, but the newer versions, there are low frequency patterns, and I don't have any that I can actually take apart that's not in a radio already, or I would take it apart and show it to you. What they basically do, they're actually in parallel. Looking for a pencil here. See if I can draw this out. Basically, hope you can see that, but basically all it is don't laugh at my drawing. You got the screw coming down through, but there's be 6 plates here, and they're just connected on one side, 3 plates here, and on this side 3 plates here. That basically makes it, it's actually like 3 separate capacitors in parallel, so you increase the capacitance, and that's all they do. And then that way they can make the physical size of it smaller, and you don't have this huge giant thing, which does cause problems. When the bigger they get, now you got a bigger plate area there, you got a bigger piece of metal that can act as an antenna and pick up interference, and I think that's where part of the squeals come from, these wires feeding it back into that some signal. It was causing a backfeed. But I hope that kind of answered that one, and as well as the switch, and as well as the biasing. Other than that, I'll kind of get set up and see about doing the alignment on this. I might go ahead and videotape that, get it all set up here in a day or two, so that we have video on that. And as far as the rest of the comments, for the most part, you guys just telling me it's a great video and everything. I appreciate that, guys. I really do appreciate all your comments and everything, even if I haven't seemed to have time right now to get back to them. I will do a demonstration probably in the next video on restuffing paper caps. So I'll just tear one apart and show you basic, or how I get them apart, what I do, and show you the procedure, at least what I do to put them back together. So anyway, I think that's about all I can think of to say on this video. I'm just kind of looking here on the screen. Yeah, I think that kind of... Yeah, I think that pretty much... Y'all like the DeForest course book. It's neat, and maybe sometime I'll try to see if I can get, maybe later this summer, taking it apart and try to scan it in. There's a lot of pages. But if I can, I'll get it in there and stuff. Speaking of which, I do have a question, and for you guys, I just want to get your opinion on it. Here, I don't know, about 3 or 4 years ago, I bought a DVD off of eBay, and it was scanned in. It wasn't real expensive. It had been more than 3. It had been more like 5 years ago. But it's the full set of riders, volume 1 through 23 for radios, not TVs. And anyway, my question is if I was to, I just uploaded it onto the computer. I took it off. It's still on the DVD, but I mean, I just copied it to the computer. You guys think would there be any, I mean, I'm not trying to make money off of it, so I'm not selling anything, but any type of, because I don't know if he actually copyrighted, the writers itself is not copyright protected, obviously. But as far as me taking that and copy it, put it onto my Google Drive, so any of you needs to, look up a schematic or whatever, it would be there. You just go to my Google Drive and look it up, and you print it off. You can't pull you can only print them. Otherwise, the whole volume has to be moved. But you guys think there would be any problem with any type of copyright type thing on that? You know, whether that would be a problem or not, me just sharing it with anybody who would be interested in, you know, they got a radio they need to look up. Because the nice thing about it, these are well scanned, so they're a lot better like in Nostalgia Air. So anyway, that's my question. So just let me know what you guys think. Other than that, I think until the next video, thank you for all your wonderful comments you guys have, and I've got a couple new subscribers. I want to thank you guys. And so I hope that answered any questions. If you got any others, just go ahead and put them on here, and I'll try to get a video made up for that. So till next time, thanks again, guys.